This is how the calculator that we'll be creating in this tutorial will look like. As you can see, it is resizable. It can be used without the mouse by just using this keyboard keys. A proper beep sound is played every time a key is pressed, and the best part is that by the end of this tutorial, you will be able to create your own GUI calculator in Python using the Tkinter module. What's up Pythoners? Welcome back to my channel. In this tutorial, I'm going to be showing you how you can create a GUI calculator in Python from scratch. I'm also going to be building the calculator in front of you and side by side be explaining each and every line of code that I write so that you guys can understand the code rather than just copying the code. So we will start by creating the folder and opening the folder in Visual Studio Code. I'm using VS Code for this tutorial. You can use any IDE or text editor you want. If you want to know how to set up Python and Visual Studio Code, you can check out this video I made on this topic. With the Python and VS Code setup completed, we will create a file by the name main.py, which will have our calculator code in it. We are gonna start off by importing the Tkinter module. Just to give a quick idea, Tkinter is a built-in Python module specifically designed to create simple GUI applications in Python. And since we are building a GUI calculator, we are going to use this module in Python. Now the next step will be to create our GUI window. In order to do that, we will create an object of the tk class. We can do that by typing tk dot capital T and then small k followed by round brackets. We are gonna store this object within the root variable. So whenever we refer to the root variable within our code, we actually refer to the Tkinter window. In order to run our GUI application, we will have to call another function of the tk class called the main loop function. Basically, it is a function that calls an infinite loop that checks for events within the Tkinter window and acts accordingly. This function is really necessary as the window will not be rendered, or in other words displayed, if we don't use this function. We will now save this file and just check once if the script runs properly or not. As you can see here, the script has been executed properly and a Tkinter window is now created and displayed to us. Now for the next step, I would like to point out something. As you can see here, the word tk is written here. We are going to change this text and write calculator in place of it, because obviously we are creating a calculator, right? We will just close this program and write root.title calculator. This line of code will set the value of the title text as calculator. If I run this script, you can clearly see here that the tk text that we saw earlier is now replaced by calculator. You guys can name it whatever you want, just make sure to pass a string in the title function. For the next step, we will change the dimensions of this window. To do that, I will call the geometry function, which is used to set the dimensions of the window. I've already thought of the calculator's dimensions to be 400 pixels in width by 400 pixels in length. So I'm gonna write 400 x 400 here as a string. The first value represents the width in pixels and the second value is the height in pixels. Now if I run this program, you guys can see that the window created has a different size now, which is 400 pixels by 400 pixels to be precise. You can experiment with different sizes like 600 by 600 or maybe 800 by 600. It all depends on you. Now that our window is properly set up, it's time that we start adding text boxes and buttons within it. I have a screenshot of the calculator with me that we are going to make. As you can see here that the top 1/4 of the window is occupied by the text box and the lower 3/4 of the portion is where all the buttons are located. So we are going to start by creating two frames, one for our text box and one for all the buttons. A frame in Tkinter is basically like dividing the window into different portions for the purpose of placement of widgets. In order to create a frame for text box, we are gonna write output underscore frame equals to tk dot frame f capital followed by round brackets. Here frame is the class used to create a frame. We are gonna pass 3 arguments in it. First will be the root, as we are mentioning to Tkinter that a frame should be a part of the root window. Next, we pass width of the frame. We want our frame to be as wide as the root window, so the width will be 400 pixels. And since the text box occupies 1/4 of the root window's height, we are gonna mention its height as 100 pixels, which is 1/4 of the total window height, that is 400 pixels. We are also going to pass background as red so that we can see our frame in the window, else the frame would be completely invisible. Now we are going to type output underscore frame dot grid to place our frame within the root window. We are going to mention row as 0 and column as 0. Grid basically uses a table-like format to place widgets in Tkinter window. We are mentioning row and column as 0 as we want the frame to be at the top. Before we run, we have one more thing to do. Below the line where we wrote root.geometry, we are gonna write root.grid underscore row configure 0 weight equals to 1. Then root.grid underscore row configure 1 weight equals to 4. And then root.grid underscore column configure 0 weight equals to 1. Let me explain you these lines. Basically, grid row configure and grid column configure are used to mention how much portion of the total area will each row and column will occupy. You can see I have mentioned for row 0 to have weight 1 and row 1 to have weight 4. It means that row 0 will occupy one of the portion of the total window and the row 1 will occupy 4 portions of the total window relative to row 0 occupying 1 portion. Similarly, column 0 will occupy 1 portion of the total window. Since I have configured only column 0, it means that only column 0 will occupy all the portion compared to any other column. The best thing about this is that the ratio remains constant even if you resize the window while the program is running. The widgets will automatically resize themselves according to the ratio. Now if I run this program, you can clearly see the red frame occupying some space of the total window size. The problem is if I try to resize it, the frame is not resizing. To make it work, we will add within output underscore frame dot grid a new parameter, sticky equals to tk dot nsew. NSEW stands for north, south, east, west. Basically, it will make the frame stick to all the sides of the area within its grid. Now, if I save and run this program, you can see that the frame will now resize itself if we resize the window. This means that the program is working correctly. Just like the output frame, we will create a button frame for all the button we will place. I will just copy the output underscore frame code and make a few changes, like changing the variable name to button underscore frame here and here. Then we will change the height of the frame from 100 to 300 as this frame has to occupy 3/4 of the window area. Then we will change the background color to green so that we can see the frame properly. And finally we will change row to 1 as we want the frame to be below the output frame. Now if I save the code and run the program, you can see that our green button frame is perfectly placed and it also resizes as we resize the window. Now we will add the text box within our output frame. To add a text box, we will type output underscore text box equals to tk.entry. Entry is the class used in Tkinter to create a text box widget. We will pass a few parameters in it. First will be output frame, as we wanted the text box to be created within the output frame. One thing to note here is that only a tk class object, a frame class object, or a top level class object can be passed within widget classes like this entry class. We have already seen tk class object, which is the root in this case, and also the frame class object, which is output frame. I will explain top level in Python in another tutorial. After passing the root parameter, we will pass the font parameter. We will keep the font as Calibri with a font size of 30. Next, we will set the state of the text box as disabled, as we don't want to directly type within the calculator text box. Instead, we will use buttons to type within the text box. This way, we can make sure that no alphabets or special characters are accidentally typed within the text box, and the program does not give any errors. Next, we will set the disabled background as bisque, as I want the text box background to be of bisque color when the text box is disabled. Then we will write the background as bisque and foreground as black. Bisque here is actually the name of a color. You could also use hex codes here to get the color of your choice. Then we will write output_textbox.pack. Here pack is used to place the text box. We are using pack as we want the text box to fit the whole area of the output frame. We will pass two parameters in it. Fill equals to tk.both and expand equals to true. Fill equals to tk.both specifies that we want our text box to fill both the x and the y axis of its parent, which is the output frame. Expand equals to true means that the text box will expand and change itself according to the changing screen size. Now we will save the code and let's see what happens. As you can see here that our red colored output frame is now replaced with the yellow colored text box. Since it is disabled, you cannot type directly in it, but we will programmatically add a text in it as we keep building our calculator. Now is the time we start working on button widget. Below the line where we created our button frame, we have to write the following lines. For I in range 4, button_frame.grid_row configure I weight equals to 1. And below that, button_frame.grid_column configure I weight equals to 1. Let's try to understand what's happening here. We know that we are creating a 4x4 grid for all the buttons, as you can see here in the screenshot. So you need to configure our grid in such a way that each of the 4 rows occupy 1/4 of the height, and similarly each column occupies 1/4 of total height in the button frame. So we are achieving that by giving each row and column weight 1, and you are using a for loop to do the job without writing longer code. As you can see here, the loop iterates from 0 to 3, representing each row and column. And as it does that, row configure and column configure is used to give each row and column weight of 1. I hope that cleared your doubt. Now it's time that we add buttons to it. We can do that by typing button_1 equals to tk.button be capital, followed by round brackets. Button here is the Tkinter class used to create a button widget. We will pass a few parameters in it. As always, the first parameter will be to mention which frame should this button be a part of. We will mention button_frame as we want our button to be within the button frame. Next, we will set the font as Calibri with a font size of 20. We will also set text as 1 as we want to display number 1 on the button. Next, we will mention its width to be 6. Here 6 is not the pixel size but the size occupied by 6 letters of font Calibri with font size 20. Now we will mention the background color as pink and the foreground color as black. Now the next line we will write button_1.grid. We will pass the row as 0 and the column as 0, as we see in the screenshot that the button is at row 0 and column 0 in the button grid. Also, we will pass sticky equals to tk.nsew so that the button property resizes with the Tkinter window. Now we have to make 15 more copies of buttons like this to create a total of 16 buttons. All the buttons should have unique variable names, their rows and columns will be unique, their text will be unique, rest all will be the same. I already have done it here so that I don't waste much of your time doing it here. Let me just quickly explain what I have done here. As you can see, we have buttons 2, 3 all the way up to 9 and 0. And then we have buttons for plus, minus, multiply, divide, dot and equal sign. We don't have a clear button for clearing the screen, so instead of a button we will use keyboard keys to clear the screen. I will explain that later in the video. I have also updated the rows and columns as per the screenshot that we have, where we can calculate the rows and columns of each button. For example, button 9 will be in row 2 and column 2 as rows and columns start from 0. Now we will run the code and let's see how our calculator looks like. And as you can see, we have our button perfectly placed. And you gotta admit it looks kinda cool, isn't it? Now that the GUI portion of our calculator is complete, it's time we start working on the calculator logic. Creating the logic won't be that difficult to understand, but you will have to focus on understanding how to integrate the code logic with the GUI part. We are going to start off by creating a function that will be called whenever a button will be clicked, which will show the number on the output text box. So we are going to go above the line where we declared root, and then we will write def print underscore number followed by round brackets. Within the round brackets, we will write number, as this function will take the number that has to be displayed on the text box as the parameter. Since the text box is disabled from start, in order to write the number on it, we will first change the text box state to normal. To do that, we will write output underscore text box dot configure, and then within round brackets we will write state equals to tk.normal. This will change the text box state to normal. Now we have to write the number onto the text box. For that, we will write output underscore text box dot insert tk.end str number. Insert function is used to insert value within the text box. The first parameter value is tk.end, which basically means that the text will be added from the end. That is, if there will be any text within the text box already present, this text will add from the right side of the already present text. The second parameter is the text to be added. Since it requires a string argument, I have passed the value of the number within str to make it a string. And finally, in order to again disable the text box, we will write output underscore text box dot configure, and again within round brackets state equals to tk.disabled, which will again bring back the state of the text box to disabled. This completes this function. Now we want this function to be called every time a button is clicked, and for that we'll have to set this function call on the button click of each button. Before we do that, we'll go to the top of the script where we had imported Tkinter and type from functools import partial. We would be needing the partial function, as this function will allow us to attach any function with parameters to any Tkinter widget. Let me just show you what I mean. We will go to the line in our code where we declared button 1, and below the line we will add a line like this. Button underscore 1 dot configure, and then within round brackets command equals to partial, and then again within round brackets print underscore number comma 1. What this line will do is attach this function call with button 1. Now every time someone will press this button, this function will be called with parameter number equals to 1, so that the function will display 1 on the text box. Since we could not directly call the print underscore number function with parameter 1 the normal way, we had to use the partial function in order to create a new function which is like print underscore number function but with parameter number as 1. Let's save our file and see how our program works. As you can see, if I click on the button with number 1, numeric 1 is displayed on the text. If I click on the button multiple times, the number 1 keeps adding on the text box. Now that you are clear with how the button click can be used to perform any task, all we need to do is to write the same line but for all buttons in the calculator. So let's do it. Now that the code is updated, let's run and check if the number buttons are working properly or not. As you can see here, all the number buttons are working just fine, and that means it's time we move on to other buttons. Now the plan for the calculators working is that the add, subtract, multiply, divide and dot button will simply add the respective symbols onto the output text box, and we will simply evaluate the output all together by analyzing the text on the output text box. So I'm just gonna use the same print underscore number function for add, subtract, multiply and divide function, but I will pass symbols as parameters instead of numbers. If I save the file and run it again, you can see that on clicking the plus, minus buttons, their respective symbol gets displayed on the screen. And the final button to work on which is left is the equal sign, which will evaluate the expression and give the output. We would need to create a different function for that. We will go to the line below the line where print number function ends and will write def evaluate followed by round brackets. We don't need to add any parameters to it. Within the function, first we will retrieve the expression present in the output text box. We can get it by typing expression equals to output underscore text box dot get followed by round brackets. The expression variable will have the string value present within the output text box. Now, in order to evaluate it, we will use a great Python built-in function called eval. This function will automatically evaluate the string expression and give us the output. So we will get the output of expression like this. Result equals to eval followed by round brackets and within round brackets expression. And that's it. The result variable will have the output of the expression. Next, we will enter the result value in the output text box. First, we will enable the text box like we did in the print number function by typing output underscore text box dot configure followed by round brackets state equals to tk.normal. Then we will clear the text box by typing output underscore text box dot delete round brackets. First parameter will be 0, comma, length within round brackets we will write expression. Basically, delete is used to clear a certain portion of the text box by mentioning the start and end index to be deleted. Since we want to clear the whole screen, we will mention the starting index, the first parameter, as 0, and the end index, the second parameter, is the length of the expression. This will clear the whole text box for us. Then we will type output underscore textbox dot insert, and within round brackets we will write tk dot end comma result, like we did in the print number function to type our output on the text box. And finally we will disable the text box by typing output underscore textbox dot configure, and within round brackets state equals to tk dot disabled. With this, the evaluate function is completed. Now we will simply add this function to work with the equal when the equal button is clicked. To do that, we will go to the equal button and add button underscore equal dot configure within round brackets command equals to evaluate. Since this function does not require any argument, we don't need to use the partial function here. Now if I run the program, if I type 2 plus 3 and then click on equals, the text box shows me the output as 5, indicating the program works just fine. The only issue is that I cannot clear the text box from here. So now we will create a function to clear the text box. Below the line where the evaluate function ends, we are gonna write def clear followed by round brackets. We don't need to pass any argument for this function. Within the function, we will write a portion of the code that we wrote in evaluate function. We will write output underscore textbox dot configure state equals to tk dot normal, and then output underscore textbox dot delete within round brackets 0 comma length of output underscore textbox dot get, and then on the last line we will write output underscore textbox dot configure, and within round bracket state equals to tk dot disabled. These lines are the same as the one we used in the evaluate function. The only difference is that within the length function we will use output underscore textbox dot get to directly get the expression from the output text box. This saves us a line of code. Now comes the part where we have to perform an action on the program with the click of a keyboard button. To do that, we'll have to bind keys to certain functions within our program. Below the line where we set the root window geometry, we'll have to write root dot bind, and within that we'll write like round brackets, and within round brackets first would be a string which would be less than sign, capital K key, hyphen, capital B and capital S backspace, and then a greater than sign, and that would be the string, and then the next parameter would be the function name, which is clear. Basically, we are binding the backspace key of our keyboard with the clear function in the program. So whenever we will click on the backspace button on our keyboard, the clear function will clear the whole text box. Before we run our program, we have to do just one more thing. I just remember. We'll have to add a parameter to the clear function. Let's name it event. Since we are binding this function, it makes this function an event according to Tkinter. So you need to add this parameter to it. We don't need to pass any value to it or use the parameter anywhere within the function, but writing it is very important as the code will not work without it. Now let's run and see how it works. If I type any number on the text box and then click backspace, the text box gets cleared, which means it's working fine. Our calculator is now completed enough to be used in real life. But to make our calculator even better, we are going to add a few functionalities. So let's start by adding a beep sound every time a button is clicked. I have the beep.mp3 sound file with me in the same folder where main.py is situated. You guys can get it from the GitHub where I have uploaded the entire code. You can get the GitHub link in the description down below. In order to play this file, we will use a built-in Python module named playSound. We will go to the line where we had imported Tkinter module and write from playSound import playSound. This will import the playSound function from the playSound module. We'll also have to import another built-in module called threading. This module is used to run two or more functions concurrently, that is side by side in Python. We will write import threading. Now we will go to the print number function. We know that this function is called when a button is clicked, except for the equal button. So at the first line within the function we will write threading dot thread T capital and then within round brackets play sound and then within round brackets and then within double quotes beep.mp3 and then at the end dot start followed by round brackets. Basically, this line will create a thread that will perform the function of playing the sound file beep.mp3 using the playSound module, and it will also start the thread immediately by calling the start function. I will copy this line and also add it to the evaluate function so that the beep sound comes when the equal button is clicked. I have pasted the code right here. Now if I save the file and run the script, you will hear that whenever I click on a button, a beep sound could be heard. That's because every time a button is clicked, the beep.mp3 audio file is played. Hello everyone, a small update in the code I wanted to inform you all about. The code that I had wrote was running a bit slow, so I had just changed a bit of code after the recording. Basically, I created another function like this for playing the beep sound, and then I used the threading to call the function and create a thread in this line, and then I started the thread on another line. This makes the calculator run a lot smoother. Since I created a different function for playSound, the program execution became a lot faster, and thus the calculator now runs a lot faster and smoother. With that, our calculator is now complete. I hope you liked this tutorial. If you did, do like, subscribe and share this tutorial to all your Python programmer friends. In case of any doubt, you can comment down below and I will respond to it as soon as possible. With this, it's time for me to go. This is Vishesh Dwivedi signing off.